now want to look at the trace of a function. For this, I'm going to consider this function here, f of xy equal to x squared sine y over 16, and we can see the graph of this function. When we look at functions of several variables, we often are interested in how each individual variable affects the function in and of itself. The idea of this is to keep one of my variables constant while we allow the other to change, and this will be an important tool as we continue studying functions in several variables. If I once again consider my function, let's consider what happens if we hold y constant at pi over 4. So I'm going to hold y constant. So in other words, I'm going to look at the function f of x comma pi over 4. This will look at x squared times sine of pi over 4 over 16, or x squared times the square root of 2 over 32. If I go back to the graph of the function, that would be like going over pi over 4 on the y-axis and then just tracing out the curve. And I can see that by this red line here. This is the curve if I just move over pi over 4 on the y-axis and then just trace out the curve. Next, let's look at holding x constant at the point 2. In this case, I know x is 2, and I'm wondering what happens to y. This tells me I have 2 squared times sine of y over 16. Or if I simplify that, sine of y over 4. If I once again look at my graph, this would be like going over 2 on the x-axis and looking at what happens, tracing out the graph here. So this blue curve here. So this is the idea of the trace, is I go over so far on one of the axes and see how the other variable is changing the function.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.